Good afternoon, ladies and gentlemen. You're very welcome to our webinar, Lime and Fertilizer, the perfect partners for healthy soil. Yara are delighted to be running this webinar in conjunction with Kilwaughter Lime. Now, Kilwaughter Lime is an established mineral and quarry processor operating since 1939. Their headquarters are in Larne, Northern Ireland, and that's where they have a 75-acre site. Now, for anyone who has joined our previous webinars, you'll know my name is Eva Ross, Marketing and PR Manager for Yara UK and Ireland, and I'm joined this afternoon by our grassland agronomist, Philip Cosgrave, who's been on a number of these webinars, and Kevin Havekes from Kilwaughter Lime. And Kevin, you're very welcome to the webinar. Now, this afternoon, Kevin is going to take us through the importance of soil health, the implications of soil acidity, the impact of liming, and the imperatives of granulated lime. And Philip then is going to guide us through fertilizer quality versus nutrient application, and then fertilizer spreader calibration. Now, you'll see then, we will have a Q&A session at the end, and you'll see if you just scroll down your viewing screen, you'll see a section there, a question box there. So feel free to input your questions there, and we will get to answering those then at the end of the webinar. So at this stage, Kevin, I'd like to hand over to you to take us through your slides.
That's great. Thank you very much, Eva. And thank you for the opportunity to join you today. And thank you to our audience for taking time out of their schedules to join us. There's an old adage that your health is your wealth. And when it comes to soil health on the farm, your soil is your wealth. Without soil that is productive and healthy, and you really haven't a hope of having a productive farm. So when addressing soil health, there's really 3 steps that need to be taken to make sure that your soils are healthy and productive. And the first thing to address is your drainage and compaction issues. A poorly drained soil is going to be poorly oxygenated, hold a lot of water. Bacteria that need air to function aren't going to be productive, and that's really going to hold things back. And then compaction can really impact that drainage issue as well, because compaction or compacted soil is obviously going to be tighter, and there'll be less room for storage of oxygen, and it'll be harder for the roots to work their way through those soil conditions and get access to the nutrients and water that are in the soil. So the first thing to address then is your drainage and compaction. Once you fix those issues, the next thing to look at is your soil acidity. An acidic soil is going to prevent the crop, or prevent nutrients from being available to the crop that's growing. And so if you're with your acidic soil, you need to get your pH up into a range somewhere between 6.1 and 6.5 to ensure that the plant has access to all of the nutrients that are in the soil. Keeping in mind that your soil test is only going to show the amount of available nutrients, and an acidic soil prevents nutrients from becoming available. So once you've addressed your drainage, compaction, and acidity, then it's time to look at your macronutrients. And your macronutrients, if you don't have those in the right indices, get them into the correct indices. And once you've done those 3 steps, then you can start to fine tune and look at things like trace element application, biostimulants, organic matter, etc. And that'll really help to get your crop up and running. So there's no point in addressing or looking at fine tuning things if you don't have those initial first 3 steps taken care of. Looking then at the implications of soil acidity, back in the 60s and 70s, there was a grant on that paid farmers to use lime. And up until that point, soils had been becoming acidic, and the crops didn't have access to those nutrients. And so by using lots of lime and getting field pHs up where they needed to be, that made nutrients more available in the soil to the plant. And over time, the soil was mined of those nutrients. Now, about the same time that the lime grant ended was the advent of compound fertilizer, and the impact of that was quite high, and farmers were seeing a really big response from having 1 or 2 bags of soil being applied, or fertilizer being applied to the soil. Lime usage dropped off about that time, and pH began to drop, and that ended up locking more nutrients into the soil, and the impact of fertilizer was becoming less and less. And what you see now is a situation where pHs are low and the fertilizer isn't having the same impact it used to have, because what's being applied to the field is being locked away into the soil. So we walk out to a field and we see it's a bit backwards, and we have to throw another bag of nitrogen on it to stimulate things and get it going. And what we're seeing now then is a pH of 6 just isn't good enough, and we really need to come to a point where we're getting the lime back onto the fields and getting the pHs up back above 6 to unlock those nutrients that are in the soil and make better use of the fertilizer that's being applied. And that's demonstrated in this chart here, that shows even at a pH of 6, which most farmers would feel is adequate, 11% of nitrogen and 48% of phosphate is being locked into the soil, and the plant doesn't have access to that. As your pH drops even lower to a pH of 5.5, 23% of your nitrogen, 23% of your potash, and 52% of the phosphate is getting locked away into the soil and doesn't have access to those nutrients. Philip, just wondering if you might chime in there and give some Yara perspective on that slide.
Thanks, Kevin. No, certainly achieving that optimal pH is definitely beneficial for the return on investment for the fertilizer for applied, particularly for phosphate. And we see where farmers have corrected soil pH, we see a corresponding boost in both grass yields and quality.
That's a good point, actually, Philip. We get a lot of questions surrounding phosphate ability and soil pH, and it really is important to address that. And that's demonstrated even further in this slide, where we show using a blend or a compound similar to 2744 at a cost of around 300 pounds a ton, a pH of 6, 45 pound of value of that ton of fertilizer is locked away into the soil and not accessible to the crop at that pH of 6. And as that pH drops down to a pH of 5, half of that ton of fertilizer gets locked into the soil, 150 pound worth of value from that ton, and it's not available to the crop. So when it comes to lime itself and what's actually happening in the soil over time through various environmental conditions and farming practices, the use of urea and slurry and farmyard manures and that sort of thing, hydrogen ions build up over time and they form insoluble compounds in the soil, which makes those nutrients unavailable to the crop. So when we put lime on the soil, the calcium carbonate is giving a chemical reaction where calcium is displacing the hydrogen ions from those soil particles, and it's also displacing iron and aluminum, and it's making those insoluble compounds soluble again so that the plant has access to that. And so that's just your simple chemical reaction. CaCO3 plus 2 hydrogen ions gives you water, carbon dioxide, and calcium. Calcium is a very important nutrient that shouldn't be forgotten as well. And you do get calcium, a significant portion of calcium in the soil from your lime. And so calcium ions are actually quite large ions, and they can help to loosen up tighter soils that may have high magnesium levels in them. And so that calcium ion, it's quite large, and it actually will take the soil particles and push them apart in comparison to a magnesium type lime, which is actually, magnesium is a very small ion, and it actually draws the soil in tighter together and can make soils less easily drained and sticky. So calcium is really important, especially in high magnesium soils, to help combat that issue. Soil testing for calcium would also be very important to ensure a healthy soil and a healthy plant with high yielding crops. Also, when we talk about calcium, so that chemical reaction that's happening, it's creating carbon dioxide in the soil, and the soil respires and it gives off carbon dioxide. So your carbon dioxide then comes out of the soil and goes on into the underside of the leaves, and the plants take them in, and that's your carbon dioxide plus water and light gives you your photosynthetic reaction, your C6H12O6 and oxygen. So you get higher levels of photosynthesis from a soil that's been limed than you would an acidic soil. Calcium is also a major component of cell walls and therefore very important to the strength of the cell and the resistance of the plant to bacteria and insects and fungus. So the higher the calcium levels in the soil, the higher the calcium levels in the plant, and you get healthier plants, higher yield, and potentially even less lodging in cereal crops. Trace elements will also piggyback on the back of calcium to get into the plant. So a soil deficient in calcium, even if it might have adequate levels of trace elements in the soil, the crop itself may be showing deficiencies to some of those trace elements like zinc and boron and manganese and copper. If you can get the calcium levels in the soil up, those elements that are in the soil are less likely to show up as a deficiency in the plant. Lime can also have a significant impact on yield. Commonly, a lime would be applied to the soil on a winter crop. And if you were using a granulated lime, it would be applied in the springtime. Weather and timing can delay application in the spring to post-emergence in spring crops as well. So while it's never too late to apply lime, it can be really beneficial to have it in the ground at sowing to ensure nutrient availability during emergence. This helps to establish full and robust root systems in the crop. In this field trial, granulated lime was applied to the soil 2 days after sowing, and the treated portion of the field ended up with a better root system and a healthier plant, which was better able to withstand the stresses of the cold and wet winter. The following spring, during grain fill, the treated portion of the field was better able to extract moisture from the soil due to fuller roots on the plants, and therefore it put up higher yields than the untreated portion of the field. Quality ground lime has a place on the farm, but poor quality is largely ineffective. Any particles of ground lime that are greater than 1 millimeter in size will only be about 10% effective, and the remainder of those particles will sit in the soil and they won't really do anything until it's physically moved by cultivation. So a good quality ground lime can be used where field conditions are highly acidic, which would add heart to the soil, but care should be taken on fields that are prone to compaction concerns. Granulated lime, conversely, then will begin to react immediately in the soil, and it gives you a full lift within 6 weeks of application. It can be spread yourself with a conventional sower. It's easy to treat smaller fields, wet fields. It doesn't have to be coordinated with a contractor. There's little concern over compaction and dragging 20-ton of kit across the land. So it's ideal for raising, but also really important in maintaining soil pH at your target. When choosing a liming product, obviously consideration needs to be given to your starting pH and your target pH, keeping in mind that a maximum achievable lift in one season is around 0.5. Once you've achieved your target pH, it can be maintained with applications of granulated lime using a little and often approach. While ground lime can take 6, 12, or even 18 months to achieve a full lift in pH, it'll then hold the pH for about 18 months before it begins to decline at a rate of 0.1 or 0.2 per year. Granulated lime can actually be applied each spring and bring your pH to target and maintain that pH at target throughout the growing season. So with ground lime, about 18 months after reaching target, the soil begins to decline until it reaches your starting pH again and more lime is applied. This can leave a gap of up to 3 years where soil pH is not at the optimal. What we need to do is maybe change the way we think about lime a little bit. We don't put fertilizer down in mass quantities every 5 to 10 years and wait for the field to stop performing before we apply more lime. Fertilizer is applied every single year, and we should consider doing the same with granulated lime, where we can maintain that pH at target through the growing season. It will drop a little bit over the rainy winter months, but that's the reapplication in the spring. 75 to 100 kilos will maintain your pH annually. So That makes granulated lime the ideal partner to fertilizer, ensuring that pH is optimally maintained and making the best use of your fertilizer investment. Philip, do you have anything that you might be able to add from Yara's point of view on that as a partner?
No, it's very interesting to see that that particular slide, and you know the impact of kind of once-off applications of bulk lime. But look, anything we can do to maintain that optimal soil pH for longer without those peaks and troughs, I think is going to benefit crops and improve nutrient use efficiency overall.
Yeah, and that's really key, is your nutrient use efficiency, and by maintaining your pH at target, you'll make the most use of your fertilizer each and every year. So when it comes to granulated lime, we call it a financial no-brainer. We've done the math for you, looking at applying 2 tons of lime every 5 years as a program for a 20-year period, and compared that against using granulated lime at a rate of 200 kilos to the acre in year 1, 150 kilos to the acre in year 2, 100 kilos to the acre in year 3, and then years 4 through 16 using a maintenance dose of 75 kilos. So that would build you from a starting pH of about 5.6 or 5.7 into your target range of about 6.2 to 6.4. And using that program with a small dosage every year will save you 40 pounds per acre with granulated lime, over and above what you would spend using ground lime every 5 years. And that program then will actually keep your pH at target 48% of the time more than it would if you were to use a ground lime program. So with that, Philip, I'll turn it over to yourself.
Thank you very much, Kevin. And yeah, it's great to have Kevin's expertise in that whole area of soil pH. It's certainly one that, you know, there's more emphasis now on maintaining soils at the correct soil pH and how we can actually do that practically. So yeah, it's great to have Kilwaughter Lime involved in this. It's a collaborative effort, and then to have Kevin then, yeah, which were for a couple of very interesting slides. And I guess some might say that the topics that we're discussing in this particular webinar, yeah, for Yara in particular, you know, we're looking at soil pH. We don't sell, you know, we don't sell granulated lime products, but they're basically fundamental on how well our products work and our fertilizer products work. But then also, you know, fertilizer is a big investment on farms. And what we often see then is that this investment that we, you know, we need to maximize that investment or the return on that investment through buying quality products and making sure, because those quality products then have an impact on the response we get from them on crops. And then I suppose finally, it's, you know, you can buy a very good fertilizer product, but if you don't apply it correctly, even in some cases, we think we're applying the correct rate, but it's not being evenly applied because we haven't, you know, placed, I suppose, an emphasis on making sure that our spreaders have been maintained or calibrated for that particular product that we're spreading. So all of these issues that we're talking about in this particular webinar, they're all kind of interdependent, and I think certainly soil pH is becoming, you know, is certainly, you know, becoming, I suppose, a focus for farmers, but I think we should also place this emphasis on fertilizer quality and how it affects how evenly it can be applied, and then the actual equipment then that's applying that fertilizer. And this is quite a busy slide, but I'm just, this slide kind of highlights, I suppose, the issue with even spreading and I suppose some of the factors involved in how evenly we are applying our fertilizer. So I suppose firstly, it's more to point out that it's a regulatory requirement that we have to apply these fertilizers evenly. particularly nitrogen, and then in some jurisdictions it's also phosphorus. So for the likes of Northern Ireland and the Republic of Ireland, then we have to apply that phosphate-containing fertilizers evenly. And obviously, even without regulatory requirement, it's good agricultural practice to apply fertilizer evenly, and we make sure that then that we maintain the no spread zones, so around riparian areas, and also field boundaries and hedges. So the machine design has a lot to do with, machines have come on a long way. There's a lot of technology in these fertilizer spreaders, and they're capable of spreading fertilizers at very wide widths, up to 42 meters. So we may have an ambition to spread fertilizer in very wide bout widths, but we have to make sure that the fertilizer we're applying is capable to be evenly applied on those very wide bout widths. So that's an important consideration that we have to make sure that whatever fertilizer, if we want to go on those very wide bout widths, we have to make sure that the fertilizer we buy can achieve those, can be spread evenly over those wide bout widths. And I suppose the fertilizer physical characteristics, I'll go into this particular point in more detail after this slide, but they're crucial to this, in that the physical characteristics of that fertilizer determine how evenly it can be applied, how far it can be applied. And obviously that has helped. We use machine settings. So with machines, some of them have apps on phones now, where particular spreader manufacturers have apps that we can check the settings for a particular spreader. But we know that a spreader's age, that those original settings may not be 100% accurate, and even with new spreaders, those settings may not be 100% accurate. So what we want to do is we want to confirm and verify that that actual settings that we're using are actually the correct ones. So we use that through field, through tray testing and establishing calculation for how evenly the spread is. So on some accounts, there can be a difference of 50% between the actual machine on the quoted settings for the fertilizer from the fertilizer or from the spreader manufacturer, and the actual setting up the machines themselves using that. So that half the time that there may need to be tweaks with the actual machine settings to achieve the best possible outcome. And also field conditions. And this is obviously fertilizer characteristics have a part to play in this, but obviously humidity will affect the flow of some fertilizers, and also windy conditions. So particularly the fertilizers that are smaller particles, and also those with lower bulk densities, like urea, and anything that with urea in it is going to be more sensitive to windy conditions. So that'll also you have to bear that in mind in picking the fertilizer and making sure that the conditions are correct to ensure that fertilizer will be evenly applied. And how do we assess the actual evenness of this of the fertilizer? Well, basically it's through the calculator, or it's through a thing called a coefficient of variation. So that's a statistical formula that works out how even the actual fertilizer has been applied using tray tests. So we're hoping that as a minimum that CV is less than 15%. So above 15% is indicating unacceptable levels of unevenness. So whatever we want to do is we want to try and maintain it less than 15, and preferably as low as possible, preferably less than 10%. So we were last year for the grassland and muck event that was unfortunately was cancelled due to COVID, but there was a farmer survey, a grassland farmer survey carried out before that, when farmers were registering for that particular event, to attend that event. And we found that 37% of respondents didn't check settings regularly before going out to apply fertilizer. Now, and 12% only used a testing service. So there's a number of companies spread across the UK and Ireland, and then the national sprayer testing scheme is I suppose the means by which farmers can go onto their website and actually find company nearby that will have the expertise in testing their fertilizer spreader. And we would recommend that this is done once a year, considering the value of the fertilizer that we can put through our fertilizer spreaders. This would be considered good value for money, and I think it's something that every farmer should consider, regardless of the age of the fertilizer spreader that they have. So this is just two graphs taken actually from the NSTS website, and looking at the likely losses or the implications of poor spreading or uneven spreading. So we only, as we can see there on both those graphs, the one on the left hand side is looking at the impact on yield with poor spreading, with uneven spreading, and the one on the right hand side then is looking at that financial loss. And I think that's we're using a cost of £150 for a ton of wheat in that calculation for that financial loss. But as I said, 15% is kind of, you know, the maximum that we would like our CV to be. But you can see there, it's on that dotted line. I have it circled as well, 15%. But we don't actually see visible differences until we reach CVs of between 30 and 50%. And this is where with nitrogen applications. But we also see it with sulfur applications as well, where we would see visible striping, where products are used. Blends, nitrogen and sulfur blends are being used, and for whatever reason, the sulfur may not be applied evenly over the complete bout width. So there's also, it's not just yield, it's also lodging and quality. So lodging can have potentially very high losses to your crop, and that's not just on cereal crops, but also on silage crops in particular. And then quality, if you're looking at malting barley or milling wheat or silage for that matter, and we see in silage crops where nitrogen has been unevenly applied, we get hotspots for nitrate coming up to harvest time. And obviously then the areas that didn't receive the requisite amount of nitrogen or lower rates than what we thought were being applied had lower silage protein levels. So you get this mismatch of areas with low silage protein and areas then with high silage protein and also higher nitrate levels. And that can have an impact then on the preservation characteristics of that particular silage field. So just looking in closer detail at the main physical characteristics that we should be looking out for in choosing our fertilizer and choosing fertilizer product. So the physical, you know, you're looking at bulk density, size, shape and hardness. There are more, but these are the main ones. And then we'll just a slide then on, you know, on what to consider with regards to spreading straights, blends and compounds. So bulk density is very simple. It's, you know, if we compare a ping pong ball with a golf ball, you can throw a golf ball further. And so it's actually the weight for how you calculate it, it's weight for given volume. So basically you will see a figure for like a product like urea, you'll see a figure of maybe 0.75 kgs per litre. So that means there's 0.75 kgs of product per litre, and that will give you your bulk density. Now for something like a Yara Mila product or a Yara Bella product like Axan, you know, the bulk density is over 1 kilo of fertilizer per litre in volume. So obviously the higher the bulk density, the further that fertilizer can be applied. So it's an important consideration as we go further up as we try and spread in wider bout widths. And for the size range too, it's quite similar in that, you know, the bigger if we had you know, the bigger the granule, the further we can throw, the more energy it captures and the further it can go. So even though for a given bulk density, the bigger granules, if it has the same bulk density, have the capability of traveling further. So what do we want to see in that size range? If we measure, and size range is based on the diameter in millimeters, but the optimal you know, diameter is between 3.3 and 4.7 millimeters. So we're looking for the vast majority of the fertilizer to actually fall into that category. And there are graders, fertilizer graders that you can purchase. that you can actually test and which test for size range with whatever fertilizer you purchase. So that's the optimal size. We want a large proportion, the majority of the fertilizer coming in at that diameter range. And this is, you know, if we look at looking for products to spread further, well, you know, we want to have a minimum. We want to have very little in that less than 2 millimeter, because that won't travel the distances required. And fertilizer shape is another thing. The rounder the granule, the better it comes off the veins and the further it will travel. Whereas angular shaped fertilizers, and particularly if we look at blends with potash in them, usually the potash is in the form of muriate of potash, and it's quite angular. It's not round, and it doesn't flow off the disc as well. And obviously that then has an impact then in how far it can be applied and how evenly applied, because it's not as predictable, the spread pattern, and also the aerodynamics of something that's angular versus round is going to be different. So the rounder particles have better aerodynamic properties, so they can travel further and have a more predictable spreading pattern. And then I suppose the last one of these main ones is hardness. And the granules need to withstand, I suppose, the impact of handling, and also the impact of spreader veins. And as I said, you know, even regardless, some granules are quite soft, and we measure this, that basically there should be no granules that are going to crush when a force of less than 3 kgs is applied on them. So there are actually, within those fertilizer testing kits, there are granule hardness testers, which you can very easily do this. And this means, you know, you can actually check and see, you know, is that fertilizer capable of being spread over for wider distances? But also, you know, handling, that granules can actually then disintegrate, you know, during transport and when it's being unloaded then into fertilizer spreaders. So that's an important one as well, that if your granule shatters, it creates dust, and obviously dust doesn't travel very far, but then you have these the smaller fragments that aren't dust, these have less predictable spread patterns. So it's important to pick a fertilizer that's going to hold its shape and stay as a full entire particle. And another, I suppose, question I'm often asked is, you know, which is better, a granule or a prill? Is it easier to apply evenly a granule or a prill? Well, really, a granule or a prill, it doesn't really make much odds. Both of them can be applied very evenly, but it's important. I suppose the big thing with a prill is that, or an important point with a prill, and considering prills, that they've a good size. So that's where you're looking at particle size. Basically, small prills, you know, that's where we have the problems with, particularly with urea, where you have small prills, and that will impact how evenly those products can be applied. Whereas big prills, Yara have a small number of products that are prilled, and they can be applied you know, as wide as many of our granulated products. So there isn't an issue with prilled products as long as the bulk density and the size range are good enough. And I suppose on this point, Kevin, you know, would you like to give me a rundown on the Kilwaughter granulated lime product and some of the, I suppose, the characteristics, the physical characteristics of that product?
Yeah, absolutely, Philip. Yeah, really good points there in terms of density and size. The granulated lime product would probably come in about 1.25 to 1.3 kilos or tons per cubic meter. So that would be that 1.3 kilos per liter range. So the density is there for wide spreads. 2 to 5 millimeter tends to be the particle size on those products, and so they're well within that range. Round shape, quality tested to 30 to 40 newtons in terms of strength. So we're we're right in there with within your parameters for fertilizer quality with the granulated lime quality as well.
Thanks, Kevin. And look, I suppose when I said the 3 kgs, a minimum of 3 kgs for that kind of hardness, 3 kgs is equivalent to 30 newtons. So that Kilwaughter product is definitely comes in well for that particular characteristic as well. And I suppose the next thing is individual products. I suppose with if we look at straights, as we call them, or if we look at blended products or compounds, like what the differences between using those particularly those different types of products. I suppose for straights, it's quite straightforward because they're the same characteristics. They should have the same characteristics. Now, generally, bulk density will probably be similar, but there can be differences in the hardness, and those straight products may not be hard enough to to withstand, that there may be issues with that. Those granules are quite soft, and I suppose the other thing too is that the size range, that if you have a straight with a very large size range going from less than 2 to over 4.75, that is going to have a negative impact on how evenly that can be applied. But if we look at blends, then that the individual ingredients within a blend should have similar physical characteristics. So, and this prevents, I suppose, segregation when the product has been loaded into bags, but then when it's also coming out of bags, that we don't see that these smaller particles rushing out first, and then the larger products can staying to the outer margins of the bag. And also this can have, as we see in the kind of a diagram on the right hand side, we see the spread width, where we can see kind of urea, DAP and MOP. So DAP is a phosphorus source and MOP is your potash source. But we see these uneven spreading patterns of individual ingredients within a blend. So it's important to pick. So there's a real issues with urea blends in that they have quite, if you're using urea blends with DAP or MAP, there's quite considerable differences in the physical characteristics and the spreading characteristics of those ingredients. So that will have an impact on how wide those products can be applied. Now, it's important to bear in mind that with applying blends, particularly those urea blends, that if we do a tray test, or we do a CV calculation on them, and the tray test, that it's important we actually look for the individual components. So overall, the tray test might show a relatively good CV, that there's the same amount of product across the individual tubes, but that may mask the actual the evenness of the individual nutrients. So for the urea portion, they may be condensed in the tubes, kind of taken from the trays directly behind the actual fertilizer spreader, but then the heavier components within that blend then will be found in greater proportions then in the outside tubes, coming from the trays from the outside tubes. So that's an important one to look at. So CV can mask the evenness of individual nutrients. Overall, the product might be quite good, but the individual nutrients may not be quite as good. For compounds, there's no real issue with segregation on compounds like Yara Mila products or Yara Bella products. Particles have similar spread patterns. Excuse my spelling error there, but they have similar spread patterns, and also that those products, wherever you see that individual granule land, then that each one of those nutrients are going to be put in that granule. So there's going to be more landing sites per nutrient. And this is just a good representation of the landing sites. This is comparing a blended 2755 product, a very popular grassland grade using DAP as a phosphorus source, versus a Yara Mila extra grass, which is 2755 with some sulfur. But we can see there that by using compounds, you will have more landing sites. Like there's 10 times more landing sites at a given rate using the the compound product versus a blended product. So it's an important one to bear in mind as we approach the peak spreading time on farms. And finally, just if you're, I suppose the first thing is when you're going to spread a product, but this is particularly for Yara products. If you're going out to spread this March, it'd be great if you get your fertilizer spreader tested beforehand. Get some of the product, put it in it, and test it, making sure that to make sure that it's actually being spread evenly. But to find the actual spreader setting for Yara products, I suppose the first thing to do is identify the factory code on the fertilizer bag. So this can be printed on the edge of the bag, or in some places then it's printed on the inner lining on a label on the top of the inner lining of the bag. So what we're looking for there is that code, so it's that product grade code. So for this particular one, it's PKEO3G, and that's unique for that product, and also the actual factory that came out of. So it'll be generally a 3-letter indication for the factory that came out of. So that's the first thing to identify if you're looking to find the correct setting for a Yara product. And they can be found on the spreader manufacturers' apps or whether they're on their websites. After finding the code for the particular fertilizer, for the Yara fertilizer product that you're going to use, the next thing then is on the app to identify it. Now, some fertilizer manufacturers, it will be kind of listed differently, but these are just 2 screenshots from the Amazon spreader app and also the Rouch or Kuhn spreader app. So we've identified, unfortunately, the previous picture I couldn't get a picture of the actual code on the bag of a bag of Activa S. But if we look at, say, Activa S, you will see that it's Yara Meal Activa S, so we know the product we bought, and then that particular the factory code is GLO, and the product code then is that PH133G. So that's important to point out. Now, that's if you have those correctly, it doesn't make any difference whether you're picking it from the Great Britain country list or whether you're picking it from the Ireland list. And for the Rouch app or the Kuhn app, well, its name's slightly different, but if you look at it there, it's actually it contains the same information in that the 6-digit code is the same, and obviously then the GLO symbolizes the factory that's come out of. And sometimes then there will be the actual product analysis included as well. But sometimes that can be confusing, particularly for in the Republic of Ireland, where sometimes the actual analysis may appear different than what than what's used for the Republic of Ireland. In the Republic of Ireland, we use elemental analysis for phosphorus, potassium, and sulfur, whereas in the UK use the oxide values for those. So I hope that might leave things a little bit easier this spring when you're trying to pick and you're trying to get the spreader settings for a particular Yara product. And finally, my last slide, just a summary of the key points. Service and test their spreaders annually. Select the correct fertilizer product and apply it accurately at the correct rate and timing. And that's really important going forward. That we, the fertilizer that we do use, that we make sure that we apply it correctly, because we may pay a lot of attention on soil testing. Identifying, the recommendation for a particular crop, but then we need to apply it correctly. So use the correct spreader settings every time, and preferably tray test every time for every product you use, preferably tray test. You don't necessarily, if you're using the same product during the course of the year, tray test once and record then the actual settings that work best, and that's what we would recommend. And then, focus on value, not price, and select the best quality fertilizer available. Because if you buy a cheaper product, but it doesn't spread evenly or spread well, that's going to have a negative impact on that crop that you grow. And finally, for more information on spreader settings and also on good agricultural practice with regards to fertilizer spreading and fertilizer advice. Yara have a campaign on their webpage, called Be a Fertilizer Spreading Pro. And there's some really useful information contained in that page and some case studies on farmers relating their story and the importance of spreading fertilizer accurately and evenly. So I hope you found the last few slides interesting, and I'm going to hand you back now to Eva. Thank you.
Great, thanks Philip, and many thanks Kevin as well. Just a couple of key points there that I picked up on. Kevin, you mentioned then as regards, the pH of 5.0, only 50% of your fertilizer is effective. So the likes of, a popular grade there, 2744, if that's priced at £300 a tonne, you're really losing then £150 worth of its value. So yeah, which is quite remarkable. And Philip, you mentioned there, in order to get the best then from your fertilizer investment, how important it is then to do your trade testing for each product, and then look to have a coefficient of variation then of less than 15% then. Guys, we've had a lot of questions come in, so I think we'll crack on with them and and get through them here. Great mix there between fertilizer questions and liming questions as well. So Kevin, I'll ask you to kick us off there with the first answering the first question there. What are the calculations on how to work out total lime required based on a pH reading?
Yeah, thank you, Eva. So basically, basic rules of thumb when it comes to ground lime, 1 tonne to the acre will lift your pH by approximately 0.25 to 0.3. 2 tonne to the acre then would be about 0.4, 0.5 lift in soil pH. When looking at granulated lime, your rule of thumb, depending on soil type, will be 50 kilos to the acre. Will lift your pH by 0.1. So every 50 kilos that you apply would be 0.1.
That's great. And Kevin, another question here kind of ties in with that. What fertilizer is best to get from index 1 to 3 or 4 for P and K? But the gentleman who's asked the question, what is the best way to bring soil pH up to the required levels when farming with 80 to 100 inches of rainfall?
Yeah, well, rainfall is always a tough one. It's difficult to gauge just how much pH you lose in a given year. Rule of thumb, depending on intensive farming practices or lack thereof, would be a drop in soil pH of 0.1 or 0.2 per year. So I mean, you could certainly use a program of ground lime where you were applying it every 3 to 4 years at a tonne or a tonne and a half to the acre, and keeping an eye on your soil tests every 4 years to do that. Or you could definitely look at an approach where you're using a granulated lime anywhere from 75 kilos to 125 kilos to the acre annually. Will be enough to maintain your soil pH, depending, a lower rate, that 75 kilos on a sandy soil or 125 kilos maybe every other year on a heavy clay soil to maintain your pH at your target. So it's really what works best for your own farming practice and your own farm.
Great, thanks, Kevin. And Philip, question for you there. On early grass, what fertilizer would you suggest for early grass other than urea?
Well, the only other option you have if you're not going to use urea is calcium ammonium nitrate or an ammonium nitrate based nitrogen source. But I would yeah, probably a more important one with respect to whatever nitrogen source you use, but is that you include some sulfur with it as well, in that it's going to have an impact with the amount of rain we got in January and February. That soil sulfate, or the soil sulfate, is pretty much the crop available form of sulfur. That those levels are going to be quite low. So I would say that yeah, that CAN product like NutriBooster, Yara Yara Bella NutriBooster, or if you've got low P and K indices, no, there will be definitely a response to applying an NPKS product as the first application.
Thanks, Philip. And I'll just stay with you there for a minute, Philip. And a question here on fertilizer and slurry. Can fertilizer and slurry go on at the same time?
They shouldn't, and we should be leaving a minimum of a week, and some might say a week to 10 days between the application of slurry and then nitrogen. Well, it's particularly nitrogen fertilizer that we should be waiting. So we shouldn't go on with them, you know, in the space of within the same day or a couple of days. We should be leaving a week to 10 days before we go with our mineral nitrogen products, or conversely, you know, go with the mineral nitrogen product first and leave 10 days or 7 to 10 days, and then go with your slurry application. But if we go too close together with these applications, then we can have issues around about nitrous oxide emissions. So we basically have very high nitrous oxide emissions if we apply the two of them very close together, particularly where we go with mineral nitrogen immediately after slurry application. So for the good of the environment, and obviously then that will reduce the amount of nitrogen lost as well, and keep more of it in there for the actual crop to take up. So yeah, we would say leave a week to 10 days for that.
That's great, Philip. Yeah, it's a question we do get asked quite regularly on is the fertilizer and the slurry timing. And Kevin, just back over to you then. Yeah, two questions here, but we've essentially covered the first part of it. Gritty lime versus powder that blows in the wind, and then Limex versus standard lime. What are your comments?
So yeah, gritty lime versus powder lime. Obviously, gritty lime is going to be a coarser material that's going to be slower to react, and is going to have portions of it that sit inert in the soil and don't react, because once they neutralize the acid around them, there's no further acid for activity there. So certainly a powder lime is going to be more effective. The trick there is to actually make sure it's getting onto the soil. So a lot of contractors have gone to the use of a hooded boom type sower, and to make sure that the wind doesn't have as much impact on a powder lime. In terms of Limex versus ground lime, Limex is a good product. It does have a lower neutralizing value, 23 to 28% range versus a 54% for a granulated lime type product. It is a fine material, or a fairly fine material, so it's reactive enough. It does have some other elements in it in terms of phosphate and sulfate. Be a bit careful if your magnesium levels are already high, because it does have some magnesium in it as well.
Great, thanks, Kevin. And Kevin, just staying with you then, does lime inhibit parasite burden?
Yeah, so calcium carbonate, it's going to naturally buffer at a pH of 7.2. So there's nothing there in the calcium carbonate to raise the pH above that level. So there should be very minimal activity on parasites.
Okay, and then we'll take some questions then that have just come in there. Let's have a look here. From a soil health viewpoint, would it be more useful to bring the pH up with the slower acting ground limestone, and then use granulated limestone to maintain this with the little and often approach? Yeah, well, any way you get your soil pH up to target, that's really the key, is to get it there in the first place. And I mean, it's certainly achievable regardless of the product that you use. When you're starting from a very low pH, below 5.5, you may put some consideration into using more of a ground lime product to get some heart into the soil.
but certainly once you get into that 5, 6 plus range, you can raise your pH easily enough and economically enough with the granulated lime, and then your maintenance applications annually every year. Some farmers have even taken to maybe a bit of a hybrid approach with a lower pH, where they might put a ton or a ton and a half of ground lime on and work that into the soil, and then once the crop is sown or just prior to sowing, going on with a granulated lime, just a couple of bags to the acre, just to make sure that they get some quick, immediate reactivity for the crop that's getting established.
Okay, and then a question here on magnesium. For high magnesium index soils, is it worth trying to lower the magnesium level? How would you do that? Is gypsum an option? The pH level is fine, but they are wet soils.
Gypsum, it's a tough product. It's not that there's no agronomic benefit to a gypsum type product, but it is very, very slow release, where it could take 4 or 5 years before you start to see any benefit from a gypsum application. When you've got high magnesium soils, a good idea is to have a look at that calcium to magnesium ratio, and certainly get more calcium on the soil to even out that ratio if you can. Certainly using products that contain sulfur in a soluble form, some of your nitrogen fertilizers and other types of products that contain sulfur will help to grab onto that magnesium form of magnesium sulfate, which very easily leaches out of the soil. So that's sulfur use not only makes your nitrogen work better, but it'll also help to leach out some of that magnesium.
Thanks, Kevin. That's great. And Philip, over to you there, just on a question on urea. Is urea harsher on lime makeup of your soil compared to ordinary fertilizer?
Well, urea, the actual the urea causes more, like per kg of N, if we had to compare urea with calcium ammonium nitrate, the urea would cause double the acidity that CAN creates. And yeah, I guess from, as the name suggests, calcium ammonium nitrate, there's a mixture of limestone and dolmitic limestone within that calcium ammonium nitrate product. So that's what kind of reduces the soil acidification of using CAN rather than urea. So it's an important point actually to make with using urea, that it does, and there's different, I suppose, estimates of that 100 kgs of mineral nitrogen will remove, anything between up to 200 kgs of lime annually. But obviously that's more so, that's actually wouldn't be the case for CAN based products, where they would have create less soil acidity than a urea product. So it's a good one to point out, and it's definitely, as we place more emphasis on maintaining that optimum soil pH, well then, yeah, it may come to the fore in years to come. And I guess it's something that I should have asked Kevin earlier on, but Kevin, where, when we talk about settings, spreader settings for your product, the granulated lime product, where can farmers find the spreader settings for your product?
Oh yeah, great, Philip. We have on our website, Kilwaughter Lime, and you go to the G Lime product, and there are sower settings on the website. We sent some product to a company, and they tested the product through their 6 different common sowers. So the settings are all on there. A few of them are approved up to 36-meter bout widths, and I think the CV was all below 10, so you'll be happy to hear that.
Good, thanks for that. Sorry, Eva.
No bother, Philip. Good stuff. Now, and a question here. When you say fertilizer is locked in soil, is it lost when we apply lime to raise the pH to 6.5, or can we access it again? Kevin, have you comments on that?
Yeah, so your P's and your K's are immobile in the soil, so it would take actual movement of the soil to lose the P's and the K's, which would come in the term, or come in runoff from the fields. Nitrate or nitrogen, though, is very mobile in the soil, and it will leach down through the profile. So when you're raising your pH, although some of the nitrogen will be mineralized, so when you're raising the pH, a portion of the nitrogen will be recovered, but some of that will be lost for good. Your P's and K's, anything that doesn't run off the soil, that's still in the soil profile, will be made available again.
And Kevin, question here, how do I test for pH?
Normal soil test will be able to do your pH calculation. So you'll take your soil sample following your proper soil sampling protocols and getting the right number of cores and one field per sample, limiting that to the size of 2.5 hectares per sample, and you send that off to a laboratory, a qualified laboratory, and they'll send you back the results.
That's great, Kevin. And just a few, we'll just take 3 more questions. I'm conscious now we're just over 3 o'clock there. So any considerations on the timing of lime application to grazing land and grass palatability? So you've really covered some of that already there, Kevin, but maybe just some comments there on grass palatability and lime.
Yeah, so I'd often hear farmers tell me that their grass has gone a bit sour, and they put the lime on and maybe on a part of a paddock that wasn't previously being grazed very closely, that sort of thing. And the farmer feedback has been that the cows seem to graze it a lot closer than they were previously. So when your pH drops below that target level and gets down below 6, obviously the grass isn't going to be able to take in a lot of the nutrients that it should be taking in, and so there's not as much nutrient value, and maybe the palatability of the grass is a bit off. So by raising your pH up into that target range, the grass is getting more of the nutrients that it needs, and it's maybe more appealing to the livestock.
That's great. And then just finally, just before we finish up, one last question there. After lime or fertilizer application to meadows with broadleaf weed and moss invasion, how long before results will be seen with improved grass growth? And that's from somebody keeping sheep and horses.
Yeah, it's tough. Lime itself isn't really going to have a direct impact on removing weeds or removing moss on it in its own right from the soil. There is some research out there to suggest that fields maintained that at a higher pH would have less moss and fewer weeds in terms of weed pressure, and therefore the grass would be able to thrive a little bit more, but without some chemical intervention or mechanical intervention to remove some of the weeds and the moss, the lime itself isn't going to be able to take care of that issue. But once you get some chemical or mechanical means to remove the weeds or the moss from the soil, lime will certainly help to prevent those species from invading again, and that'll end up with a much more productive field.
Oh, that's great. Thanks, Kevin. Really, that is it, Kevin and Philip. Many thanks to you both there for the session this afternoon. So many thanks. Have a good rest of the day there, and we'll be back again soon. Take care. Thank you.